So now we'll see what happens when we change temperature. Now, at the beginning of that unit, we saw that there's two types of reactions. One where temperature increases and one where temperature decreases. When temperature increases in a reaction, it's called an exothermic reaction. And for an exothermic reaction, we have a delta H value, which is negative. What is delta H? So let's say we have, I'll take an example that I remember taking in class. So let's say we have wood that we're going to burn down, that is going to form ashes now. Okay, so the wood initially, so there's a large amount of energy stored in it, so its initial energy level, wood initial energy level was high, so that's for wood. So that's we'll say the energy for wood, so that's H, we'll say initial. Okay, and for ashes, the energy, because ashes, all the energy that was in the wood has been used up, so now there is very little energy in the ashes, so ashes is going to have less energy, so let's say H final. So then the change in H, which is delta H, delta is a symbol used for change, so change is in H is final H minus initial H. So final energy minus initial energy, and since the final energy has a low value, which means that delta H becomes a negative value. So we're going to cover that in more details in the next unit, but for this unit you just have to know that when temperature increases, it's called exothermic reaction, and exothermic has a negative delta H value. And the other way around as well, so when temperature decreases, it's called endothermic, and delta H is now, please make a change here, it's positive. This is wrong this is a mistake I did. Okay, so delta H is going to be positive, it's the other way around. Okay, so let me just explain again what happens in an endothermic reaction. Let's say we take an example of a leaf. So then we have the leaf. So there's the sun here. So initially there is no food in the leaf, and then there is food in the leaf after photosynthesis. So photosynthesis, going to get energy from the sun. So initially there is no energy, so level of energy will be low at the beginning. So delta H, so initially H initial, and then at the end there is food, so energy from the sun has been absorbed, so now it has higher energy, so H final. So then the delta H change in the energy would be H final minus H initial. So this is going to be a positive value because H final has a high value compared to H initial. Okay, so endothermic is going to be positive and exothermic is going to be negative. Delta H. Okay, now if in a reversible reaction, if the forward reaction is exothermic, then the backward reaction is going to be endothermic. So if I tell you that I have a reaction taking place, so reactants to products, and if I tell you that this reaction has a delta H negative, which means that as we're going in the forward direction, so from reactants to products, this is going to be exo, which means that heat is released. Okay, which means that for the same reaction, if I'm going from product two reactants, which is the backward reaction, it's going to be the reverse of it. So now it's going to be endo, which means that heat will be absorbed. We're talking about the same reaction here. Okay, so if I say that for this reaction delta H is negative, means that in the forward direction it's exo, and in the backward reaction it will be the reverse, it will be endo. You can have another reaction where I have reactants into products, but now this time delta H is positive, which means that from reactants to products, this is going to be delta H positive, that is endo. And if I'm going from products to reactants now, so the reverse reaction, it's going to be the reverse of that. So then delta H will be negative, so that's going to be exo. Okay, so this is how we are concerned about endothermic and exothermic in reversible reactions. Now, in that first example, so this reaction, so that's the reactants, that's the product. You see delta H is negative, which means that the forward reaction, so from reactants to products, this is exothermic, which means that it liberates heat. So exothermic means that heat given up, heat released. Okay, which means that from products to reactants, now the backward reaction, this is going to be endo, which means that heat will be absorbed. Okay, now let's see how the conditions are being changed now. Now, if the temperature of the system is decreased, so we are decreasing the temperature, the equilibrium is going to do the reverse thing. So we decrease the temperature, the equilibrium will oppose it and try to increase the temperature. Now, for it to increase temperature, which side should be favored? So let's see. So if it is exo here, exo means temperature go up. If it is endo here, means temperature goes down. Okay, so forward reaction, so forward temperature goes up, reverse temperature goes down. So we decrease the temperature, so now the reaction will want to increase the temperature. So which one will be favored? So temperature increase, we are favoring this one, which means that the forward reaction will be favored. So forward reaction is favored. So equilibrium will shift to the right. Okay, so amount of product increases. Let's see what will happen now if we increase temperature. Now we increase temperature of the system. What will the equilibrium want to do? It will want to oppose it. So we increase, the equilibrium will want to decrease. So then this part is favored. So decrease temperature, so that's the backward reaction. So then the equilibrium will shift to the left, which is the backward reaction. So then the backward reaction is favored, amount of product decreases, which means amount of reactants will increase, therefore yield here will go down. Okay, let's see question 1. I'll work it out for you and then you're going to continue. So you have the reaction. What will happen to the speed of the forward reaction if the temperature is increased and decreased? Okay, so let's see. Forward reactions. always for these kind of questions, write it on the side so that you don't get confused. So let's write it on the side here. So we have the reactants, we have the products, and delta H is positive. So delta H is positive. Okay, so from reactants to products, so reactants, that's the left side, this is the right side. So this is going to be positive, which means that the reverse is going to be negative. Okay, so if this is positive, means temperature goes down because this is endo, and this is negative, means it's exo, which means the temperature goes up here. Okay, so we have two different things here. Now, if temperature is increased, we are increasing the temperature, what will the equilibrium want to do? It will oppose it. So equilibrium will want to decrease temperature. Which one decreases the temperature? It's this one. So we're going to have more products formed. So speed of forward reaction increased. Let's look at the other side now. Temperature decreases. So we are decreasing the temperature. What will the equilibrium want to do? The equilibrium will want to oppose it, which means the equilibrium will want to increase temperature. Which one is increasing temperature? So it's this one here, temperature increases. So then the backward reaction is favored. So we have more reactants. So forward reaction is going to decrease. Make sure you're really understanding that and you're not just writing decrease because the first one is increase. Okay. If you still don't understand that, just let me know by a message. I'm going to try to explain it in more details. Now, attempt the next part, which is on the Haber process. So we're going to try to justify all the conditions used by the Haber process in the next example. Go back on your notes on the Haber process, find the conditions, temperature, pressure, and catalyst that we use, and then answer all these questions. So there's 2 questions here. Answer them and check the next video for the answers.